Welcome to The Explainer. All right, today we're tackling something that's, well, it's a rite of passage for every web developer. That one super common and, let's be real, incredibly frustrating hurdle, CORS. We're going to take that infamous red error message and transform it from a source of pain into a moment of clarity, because you'll actually understand one of the web's most critical security features. Yeah, you know the one. If you've spent any time at all building for the web, this error message is basically an old, unwelcome friend. It just pops up in your console, stops your app dead in its tracks, and honestly, a lot of the time, you're just left scratching your head wondering, why? So you've definitely seen the error. But do you really get what it's trying to tell you? And more importantly, do you know how to fix it the right way, not just with a quick hack? Well, let's dive in and turn that confusion into confidence. All right, Section 1, the same origin security rule. This is all about the why behind the block. See, to really get a handle on this error, we have to rewind a bit and look at the fundamental security rule that's actually causing it. And here's the absolute key takeaway. This isn't a bug you're fighting. It's a security feature. And trust me, it's there for a really, really good reason. So think about this for a second. Back in the early days of the web, there was a huge security hole. Imagine you're logged into your online banking account in one browser tab. Then in another tab, you click on a link to some, shady website. Without any protection, that malicious site could secretly fire off requests to your bank server on your behalf. It could use your active login to do things like transfer money or steal your private info. This is a classic attack called cross-site request forgery, or CSRF. And to prevent exactly that, browsers put a fundamental security guard in place, the same origin policy. Now, the policy itself sounds pretty straightforward. A script from one origin is only allowed to request resources from the very same origin. That's it. But the devil's in the details. What exactly is an origin? Well, it's not just the domain name. It's a super strict combination of three distinct parts of the URL. The protocol, so HTTP versus HTTPS, the hostname, like store.aws.com, and the port number, like 80 or 8080. And browsers are incredibly nitpicky about this. Just look at this comparison table. You might think HTTP store.aws.com/dir2/new.html is the same as the original, and yeah, it is, only the path changed, which is fine. But look at the next one. Just changing the protocol from HTTP to HTTPS? Nope, that's a different origin. A different port number, like 81 instead of the default? Different origin. Even a different subdomain, like news.aws.com instead of store.aws.com, you guessed it, completely different origin. If any one of those three things doesn't match perfectly, the browser's security alarm goes off and it blocks the request. Okay, so if the same origin policy is so incredibly restrictive, you're probably thinking, wait a minute, how does the modern web even work? I mean, we build single-page apps with React or Vue that run on one origin, and they talk to backend APIs that live on a completely different origin all the time. So how are they supposed to talk to each other if this rule exists? Well, this is where cross-origin resource sharing, yep, CORS, finally makes its grand entrance. CORS is basically a browser security mechanism that lets a server say, hey browser, that same origin rule, it's cool, you can relax it, but only for this specific website. It uses special HTTP headers to give permission for a web app at one origin to get resources from a server at a totally different one. So the most important thing to get is that CORS isn't the error. The error is the browser enforcing the same origin policy. CORS is the solution. It's a feature. It's a deliberate, secure conversation, like a handshake, between the browser and the server to agree that it's okay to share something. So it's not a bug you need to hack around. It's a controlled process for granting exceptions. So how does this handshake actually work? Let's get into the mechanics. There are basically two flavors of this conversation, what we call simple requests and the more complex pre-flight requests. So for what's called a simple request, think of a basic GET request, the process is pretty direct. First, your browser sends the request, but it adds a special header, origin, telling the server where the request is coming from. Second, the server gets the request, looks at that origin header, and checks it against its private list of allowed websites. Third, if your site is on the list, the server sends the response back with an extra header of its own, access control allow origin. Finally, the browser sees that permission slip and boom, it lets your code access the data. One and done. But what about the more complex stuff? I'm talking about requests that actually change data on the server, using methods like put or delete. Or what if your request has custom headers, like an authorization token? For these kinds of requests, the browser gets a little more paranoid, and for good reason. And this is where the pre-flight comes in. It's a genius little safety check. Before sending the actual request, the browser first sends a completely separate preliminary request using the options method. It's basically the browser politely asking the server for permission first. It's saying, hey, just a heads up, I'm about to send a put request. Is that okay with you? The server then responds to that options request, spelling out the rules, which origins, methods, and headers it's cool with. And only if the pre-flight gets the green light does the browser turn around and send the actual complex request. It's a two-step verification. And this entire brilliant conversation is all handled through these specific HTTP headers. You've got request headers sent by the browser asking for things, and you've got response headers sent by the server giving permission. Things like origin, access control allow origin, access control allow methods. This is the language of the CORS handshake. Understanding these is the key to everything. Okay, so now that we know the why and the how, let's talk about the practical side of things, getting your configuration right. Because look, it's one thing to know the theory, but it's a whole other thing to implement this correctly without accidentally punching a giant security hole in your application. So let's go over some common pitfalls and best practices. All right, let's start with the absolute biggest one, origin configuration. The bad practice? Just setting your allowed origins to a wildcard, that little star symbol. CORS allow all origins equals true. I know it's tempting. It makes the error go away. But in production, this is a huge security risk. You're basically telling the entire internet that any website, anywhere, can make requests to your API. The good practice? Be specific. Be surgical. List the exact origins, like https://app.yourdomain.com, that you trust. Lock it down. Next up, pitfall number 1, middleware order. Oh man, this one gets people all the time, especially if you're using a backend framework. You have to make sure your CORS middleware is placed as high up in the chain as possible. Why? Because it needs to see the request and add the CORS headers to the response before anything else can intercept it and send a response back. If it's too late in the line, it never gets a chance to do its job, and you'll be tearing your hair out wondering why it's not working. Pitfall number 2, trying to use credentials with wildcards. This is a big one. There's a hard and fast browser security rule that says you absolutely cannot use a wildcard for your allowed origin if you're also trying to send credentials, like cookies or auth headers. If you set access control allow credentials to true, you must specify an exact single origin, no exceptions. The browser will just block it every time. And pitfall number 3, the one that feels like a ghost in the machine, caching. So you've fixed everything on the server, you've double-checked it, you know it's right, but the error is still there. What's going on? Well, browsers are smart. They cache the response from those pre-flight options requests to save time. This means your browser might be holding on to an old, failed permission slip. When you're debugging CORS, your best friends are the clear cache button and testing in an incognito window. So to wrap all that up into a nice summary of best practices. First, always be specific. Use a restrictive allow list for your origins. Second, limit which endpoints actually need CORS. Don't just apply it to your entire app. Third, be explicit about which HTTP methods and headers your API actually needs. And fourth, if you're sending credentials, remember you need that exact origin match. Basically, you need to treat your CORS config not as a bug fix, but as a critical piece of your security setup, and you should review it just like any other part of your security. So, as we finish up here, I want to leave you with this question to think about for your own projects. Is your CORS configuration a secure gateway, or is it just a wide open door? That error message you see isn't just a nuisance to be silenced with a quick wildcard fix. It's the browser doing its job, asking you to be deliberate and define the security boundaries of your application. And how you answer that question really is the difference between a temporary fix and a truly secure application.